though, remember we were just talking about that levels that the electron could be in, and that it could be in the first energy level or the second. Remember, it's like looking up from the center of the nucleus, and you can see the electrons doing different things. Notice that these energy levels get closer and closer and closer to each other. So as you move up, there's less energy to jump between sections, and if you're trying to go this whole distance, it's much more energy that'll be released. If you're trying to jump all the way up in the other direction, that is a lot more energy that you have to have. So as they began looking at hydrogen, they found out that hydrogen actually has more than those 4 pictures they had seen before. So this is what they began doing calculations with for hydrogen, were those 4 that were in the visible spectrum. And you could hold that polarized film up and you could see them. So then people began looking in the UV spectrum, and they began looking in the IR spectrum, and they began noticing that there are other frequencies that could be detected with something besides your bare eyes. So these were the first 4. These are called the Balmer series. And notice that the Balmer series in the visible range is when you're going from like the 6th down to the 2nd, the 5th to the 2nd, the 4th to the 2nd, or the 3rd to the 2nd. That's what falls in the visible range. And then we have over here, they call this the Linman series, but this is basically the larger energy drops, and they go all the way to this first level. These are all following in the UV range. And then we have people who began looking at it in the ultraviolet, and it turns out that there are also emissions in the ultraviolet spectrum. 1, 2, 3, 4 in that spectrum. And notice this is on the upper section of the atom. Remember I said that they're closer energy, so that's why IR, that's the lower energy side, so it's not as much energy to make those transitions as it is to make these transitions. Go ahead and check out this video right here. This is Dr. Bean. She is explaining the beginning of why electrons are a little bit odd. And this is a repeat on those electrons absorbing energy. So let's talk about this word absorbing versus emitting. So we've mentioned this a few times, absorbing versus emitting. What's the difference between the two? Well, think about yourself. When you do you require or give off energy when you jump up steps? Well, when you're jumping up, you've got to put extra energy in. You require energy. What about down them? Gravity does most of the work, right? I mean, yeah, you have to put a little bit of energy in, but generally speaking, we're talking about trying to make a illustration here that makes sense. So when you go down the steps, you're going to be giving off energy. So this right here, this is absorbing. You would have to absorb. You yourself would probably be absorbing energy from your food. The electrons will absorb the energy and immediate react, whereas you're going to have absorbed it, and you'll have the energy that's stored that you're going to be using. But absorbing energy is when you require energy. And then emissions or emitting, that's when you are going to be giving off energy, or when something else is going to be helping you move down those stairs. So again, do the orbits get closer together or farther as they move from the nucleus? So look at this spacing. This is from 1 to 2, first to second, and then up here. That's the 6. Well, actually, let me not do that one. Let me do 6 to 5th. You can tell this distance is more than this distance. Will it take more energy for an electron to go from 1 to 4 or 3 to 4? Well, let's look. So if we want to see a 1 to 4, it's actually right here. 1 to 4 versus 3 to 4. Let's find him. Or 4 to 3. Here it is. So you can see the wavelength here, 97. The wavelength here, 1875. So the energy is going to be a lot higher energy over here. Wavelength and energy are inversely related. So if you have high energy, you have high frequency, but you have low or long wavelengths. Or small. So this is a smaller wavelength than this one is over here. So this is lower energy, lower frequency, and this is a larger wavelength, is a way to think of it. Would it take more energy for them to move? It would take more energy. If you go in this direction, it's the absorbing energy. If you go downwards, that's the emitting energy. It's emitting it outwards. to somewhere else. It sends the energy off as a wave. So absorbed energy is when energy is released. It's when moving from, I'm sorry, I said that backwards. Absorbed energy is when energy is absorbed. It's when it's required. It's when it is added to the electron, when you're moving from a lower to a higher. And when we talk about energy in chapter 9, we can reference back to this, it'll make more sense, but that's positive energy. Emitting energy is when energy is released and it moves from the higher to the lower orbit, which is negative energy. If the electron absorbs more energy than the highest possible orbital, then it leaves the atom with that energy. That is ionization energy.